Okay, trig. This is a fun one. Trigonometry. So we're going to take section 4 and split it into 2 parts because there's a lot of trig in this section. So this will be good. It's always good to understand basic trig ratios. And so that's where we're starting. The ratio, and you remember what ratio is? You're comparing two values, right? Comparing them. Of the lengths of 2 sides of a right triangle is called a trigonometric ratio. That's probably a good spelling word for us. Trigonometric. Oh, I did it again. Trigonometric ratio. Whew. Okay, the 3 most common ratios are sine, cosine, and tangent. Okay, and this is the actual ratio right here. So the sine of some angle A is the opposite side over the hypotenuse of the triangle. And the cosine of some angle A is the adjacent side over the hypotenuse of the triangle. And then the tangent, these are the short ways that they write them. The tangent of some angle A is the opposite side of the triangle divided by the adjacent side of the triangle. So let's look and see what this would look like. These ratios are often remembered by the phrase so, ka, toa. All right, and you might have heard that. You might have worked with this before, so this is not new to you, but this says the sine is the opposite over the hypotenuse. Did you see sine, opposite over hypotenuse? And this one says cosine is adjacent over hypotenuse. That was this ratio here. And then tangent is opposite over adjacent. So this has pulled me out of many a tight space when I was taking a test in college to try to remember SOHCAHTOA. Okay, find the sine of angle R, the cosine of angle R, and the tangent of angle R. So let's first identify where angle R is, right here. And if that is our main angle, which side is opposite that angle? So we'll go all the way across the triangle, and over here, this will be opposite is R. Which side is the hypotenuse? That would be this one. And then which side is adjacent to R, but not the hypotenuse? So the adjacent and the hypotenuse are never the same. And that would be this guy. Adjacent, remember, means right next to. Like your neighbor that's adjacent to you is in the house right next door. So the adjacent side is right next to the angle. Opposite is on the far side. And then hypotenuse is that longest side. Okay, so the sine of R is, now let's look up here, the opposite side over the hypotenuse. So this will be a fraction. We're comparing. Opposite side is little r. And then hypotenuse on the bottom is little t. Okay, let's do cosine. The cosine of R, it's going to be a fraction again. Cosine is adjacent over hypotenuse. So from that R, which side is adjacent? Little s. And the hypotenuse is still t. Last one, tangent of R. Tangent is opposite over adjacent. So we'll go to that opposite side, little r, over the adjacent side, little s. That's it. That is the sine, the cosine, and the tangent of angle R. So I want to give you a chance to find one, but first, let's erase our marks on here because this is going to change when you look at a different angle. These will not be the same. Well, actually, the hypotenuse will still be the same. I should have left that one there. Hypotenuse stays. You're going to find the sine of S, the cosine of S and the tangent of S. So this is your main angle now. Identify which side is opposite and which side is adjacent before you start, and then find those three ratios. Pause your video, take a minute and work on that. Okay, all right, let's see. Sine of S. So this side is opposite. This side is adjacent. And there are only three sides in a triangle. So there's going to be lots of relationships here that you notice. The sine of S, so opposite over hypotenuse, so S over T. Cosine of S, so adjacent over hypotenuse. And then the tangent of S is opposite over adjacent. Okay. Hopefully that's exactly what you got. Do notice, though, that there are some relationships here. Sine of R and the cosine of S match. Cosine of R and sine of S match. And there's even a relationship here with the tangent, right? Inverse. Okay. All right, let's see. Let's try this with some actual numbers. So this is where it gets to be more fun. This says find the sine of A, the cosine of A, and the tangent of A. Express each ratio as a fraction. So this time we'll have actual numbers in that ratio that make it a fraction, and a decimal to the nearest hundredth. Okay, let's do sine of A, cosine of A, and tangent of A. And we'll do the fraction first because that's the logical way to do that. And then we'll take that fraction and we can turn it into a decimal. So if A is our main angle, here's the hypotenuse. Which side is opposite A? Yep, way over here, all the way across to the opposite. And then the one that's right next to him would be the 12. So here's our adjacent. Sine of A, sine is opposite over hypotenuse. So 5 over 13. And if we want to make that into a decimal, 5 divided by 13 is, we'll say 0.38. 0.38. Okay. Now let's do cosine. So cosine is adjacent over hypotenuse. That would be 12 over 13. And we'll make that a decimal. 0.92, 0.92. Okay. And then our tangent, and do you remember what that is? Opposite over adjacent, so 5 over 12. What's a good decimal for that one? 5 divided by 12. 0.42, we'll round that up. 0.42. Okay, those are the trig ratios for angle A. Let's do, because it does ask us now to go ahead and do B. So we'll do sine of B, cosine of B, and tangent of B. And I'm going to erase this. That's no longer my main angle. And I also want to take this off and this off. And hypotenuse stays, right? He doesn't change. Now we're looking at angle B. The opposite side would be 12. This guy's op now. And this guy's edge. Okay, let's try. So the sine of B opposite over hypotenuse will be 12 over 13. And look at this relationship again with the cosine of A. And then cosine, so adjacent, which is 5 over hypotenuse. Yep. And notice that he's looking pretty similar to the sine of A. Tangent. Tangent is opposite over adjacent. So we've got 12 over 5. And as far as decimals, well, I already know that. I already know this one. I don't know this one, though. He is the inverse. What's the inverse of that? 12 divided by 5, 2.4. Okay, so they don't all have to be 0 point something. You could end up with a number that's bigger than 1. All right, I got one for you to try. Slightly different triangle, right? Find the sine of j, cosine of j, tangent of j, fraction and decimal, and then switch it around and do angle L. Use angle L. So pause your video and work on that for a second. All right, let's do some checking. Did you get sine of j, cosine of j, tangent of j? If this is our main angle, well, he's going to be the hypotenuse no matter what. Opposite, adjacent. So sine 12 over 20, cosine 16 over 20, and tangent 12 over 16. And this would be, that looks like a, 0.6, 0.6. I'm guessing 0.8. Let's make sure, 0.8. And what's this one? 12 divided by 16. That sounds like 3/4 or 0.75. Do we match? Okay, and then we swapped it all and did sine of L, cosine of L, tangent of L. So we erased this. And L, this is now adjacent. And this is opposite. We have 16 over 20, 12 over 20, and 16 over 12. Are we matching? 0.8, 0.6, and then 16 divided by 12, 1.3 repeating, I'll say, or 3 repeating. If we try to stick with our 2 decimal places. Okay, hopefully you got that. You're getting that whole tangent idea. You guys are doing trig ratios. That's awesome. Let's look at the back. So one thing that's really cool about this is that if we are missing sides or angles on a triangle, we can use trig ratios to solve for those missing parts. And we're going to work on sides first. We can use trig ratios to find missing side lengths on right triangles. Okay, and this is how we're going to do it. We're going to label sides. So it really helps to know adjacent, opposite, hypotenuse, to keep that very clear in your mind what's what. Identify which trig ratio to use. So if you have opposite and hypotenuse, you want to pick sine. If you have the adjacent and the hypotenuse, you want to pick cosine. And if you have opposite adjacent, you want to pick tangent. So you got to be really clear about which one goes with which pieces. Then you set up an equation and solve for x. And you are going to need a calculator for this. And you're going to need a calculator that says on it sine, cosine, and tangent. So there are some online ones that might be helpful too if you can't find a calculator like that. I think those are even on phone calculators though. Not that you can use your phone on a test, but if you're at home trying to do this, you could figure that out. Okay, let's go down here and try this out. So this guy he's a triangle, he's a right triangle. They gave us this 24 degrees, and compared to that angle that we do know, this is the opposite side. This is the hypotenuse. So I just did this label side, step number 1. Okay, I figured out what pieces I have in comparison to that angle. Step 2, identify which trig ratio would go well with this. So if I have opposite and hypotenuse, and I'm just going to write up here, so, ka, toa. I have opposite and hypotenuse. That means I want to work on sine. The sine ratio is the one that's going to help me the most. Set up an equation. The sine of x equals opposite over hypotenuse. Let's see what pieces we have that we can plug in. Well, we do have the angle measure. So sine of 24, and that's where that angle would go. Uh-oh, my battery is going to die. Hold on. Okay. Sine of 24, we put that in there, equals, now we need the opposite side. That's the x value that we don't really know. That's what we're solving for. Over hypotenuse is 9. Okay, so you see where the pieces go. Opposite, hypotenuse, and the angle measure goes into this spot. Okay, now I want to solve for x, and he's divided by 9. So we're not done until x is all alone on one side. Let's multiply by 9, multiply by 9. And then those guys cancel. If you multiply by 9 and divide by 9, it goes away. It turns just to 1. Over here, so this says 9 times the sine of 24 equals x. This is where you're going to want to pull out a calculator. We did this, solve for x, and then use a calculator to finish. So we're not going to leave it looking like that. Grab your calculator. And if you have one of these TI-84s, check really quick, push mode, and make sure that you're in degrees, not radians. So degrees should be highlighted. You will get the wrong answer if your calculator is turned to radians. That's something you'll need later, not for this class. So make sure you're in degrees. Second, quit. Okay, and then I'm going to type it in just like this. 9 times sine of 24 and hit equals or enter 3.6. We're rounding to 2. 3.66 equals x. That is how long this side is. We just found a missing side for a right triangle by using the angle opposite it. All right, I'm going to do one more with you and then give you a chance to try a couple. So missing sides, we want to first figure out what sides we've got in comparison to the angle that's here. So 37 degrees. Well, this is hypotenuse. Is this opposite or adjacent to that angle? Yeah, this would be opposite. We don't have him, so this is adjacent. Okay, step 2, which trig ratio goes with that? If I know A and H, let's scroll back up here, that's going to be a cosine. So I want to use the cosine this time because the cosine of x equals adjacent over hypotenuse. Now let's plug in what we've got. Cosine of 37 equals, adjacent is 48 over hypotenuse is x. Okay. Interesting. Cosine of 37. Now, how can we get x all by itself? He's on the bottom. Yeah, this will be a two-step problem. We need to multiply by x, and in that way, we get him out from the denominator. This is multiplied by x and divided by x, so that's just a 1. Over here, we have x times the cosine of 37 equals 48. And x is multiplied by the cosine of 37. We just want x by itself. So let's divide by the cosine of 37. Got to do it to both sides, right? In algebra, it's all about keeping it equal on both sides of the equal sign. multiplied by cosine of 37 divided by cosine of 37. So x equals 48 divided by the cosine of 37. Now you pull out your calculator. 48 divided by cosine of 37 is 60.10. I'll put a 0 there. Okay, so we solved. This time it was the hypotenuse that we didn't have. We solved for the hypotenuse using cosine. That was awesome. All right, I've got 2 here for you to try. Pause your video. This might take more than just a couple seconds, and find those missing angles. And then come back and we'll check. Okay. All right, let's try. So we've got a triangle. Here's our 55 degrees. And right next to it would be, this is hypotenuse. They didn't give us that one. They did show us the opposite and adjacent. So which trig function works with opposite and adjacent? Tangent, right? So tangent of x equals opposite over adjacent. TOA. So TOA. All right, so tangent of, let's plug in our measure. Opposite is x, adjacent was 8. Okay, awesome. So we want x, let's multiply by 8, multiply by 8, multiplied by 8, divided by 8, gone. So 8 times the tangent of 55 equals x. Pull out that calculator. 8 times the tangent of 55, 11.43 equals x. That opposite side is 11.43. Sounds good. Awesome. Let's do this last one. Okay, here's what they gave us. This is our hypotenuse, and this is right next to it. So that's our adjacent side. If we have A and H, that's cosine. And that is adjacent over hypotenuse. Let's plug in then the pieces. Cosine of 43 equals adjacent's 36. Hypotenuse we didn't know. And we need to get that out from under the fraction, multiply, divide. So that's just plain old 36. X cosine of 43. And if that's what we want alone, we need to divide, gone. X equals, pull out my calculator, 36 divided by cosine of 43, 49.22. Done, and we found the hypotenuse on that triangle. Okay, I want to give you guys some time to practice some problems. You've got an assignment to work on. And next time we're going to work on solving for a missing angle. So there is more we can do with trig ratios. All right, have fun.